Okay, let's have a look at this one. Determine the heat energy required to change 45 kilogram, question number 8, of water at 20 degrees centigrade to superheated steam at 150. Find the given the specific capacities of the water, the steam, and the latent heat of vaporization. We all given that one. So we need to actually break it down into steps. We know the mass. Let me do on the next page. Okay, the mass is 45 kilogram. Then we have a T1. T1 is 20 degrees centigrade. Is it 20 or 25?
20.
20 degrees, thank you. And then it's still water. So, and then we got the specific heat capacity of the water. This is the water data now. Specific capacity of the water is 4,200 joules per kilogram centigrade or Kelvin. To be honest, it doesn't matter because we're looking at change in temperature. This is still water. So first thing, it's all water. Now the T2 for the water is going to be 100 degrees centigrade. So that we assume is a pure water. So first we need to find out how much heat the thing absorbed to convert the water from 20 degree to 100 degree, and we assume it's still water. So first we need to do this bit for the water one. So let's do that one for the water one. Actually, let's use the same color for the water. So change in energy required or energy is absorbed is mc delta T. And I'm just going to put instead of M 45 kilogram, instead of C 4,200, and the change in temperature delta T here is going to be 100 minus 20, which is just 80 degrees centigrade. So 80. So if you put that in your calculator, you will get an answer in joules. Convert that one in megajoules if you want to.
Was T2?
So if when you do that one, you will get an answer 15.12 megajoules. Mega is 10 to the 6. So 1512, and then there are so many zeros. So you can press the ENG button, it converts into megajoules. So this is going to be your first answer. We are still in water. Now the next thing we need to do is we need to convert this water into steam. So now the second stage is convert the water into steam. Converting 45 kilograms of water, liquid water, into steam. Now, then how much energy is required? The mass is 45 and the L latent heat of evaporation. Let's go back. What was the latent heat of evaporation? A big number is 226 and then 4 zeros. So 226 and 4 zeros. That's joules per kilogram, Kelvin or centigrade. If you got 1 kilogram of water, this is the energy you need to convert into steam. Okay, I can convert that into 1, 2, 3, 4, 5, 6. I can convert that into megajoules as well if I want to. 2.26 megajoules per kilogram centigrade. Oh, you mean that one, L?
Yeah, I don't understand how's that fitting into this equation.
Now we're moving from liquid to steam.
Yeah, that's operation, isn't it?
Yeah, so the thing for steam was that 226, wasn't it? 226.
Yes. So if we go back, first what we need to do is this question comprises two parts. First is you heat the water from 20 to 100 degrees centigrade. Then you convert the 100 degree into steam. And then you superheat the steam. Then you heat the steam. So here, this stage 1, the formula is going to be delta E equals to mc delta T. For this one, you are converting into steam. So delta E equals to ml evaporation. And this one is again going to be delta E equals to mc delta T for the steam. So there are 3 steps. You're providing the heat energy. First step is you heating the water from 20 to 100. That's the formula. Mass of the water, mass specific of the water, change in temperature of the water. Now we convert the all 44 kilogram of the of that thing water into steam. Now this is the formula ml evaporation or mlf. These are 2 formulas which I hadn't mentioned before. This is the formula that actually we use if the state is changing. Now the state is changing, and this is steam. I'm converting the steam to the higher temperature, so I'm going to use the same formula. So let's go back. Okay, so if I want to do the change, is ml evaporation is 45, and that is 2.26 megajoules. Rather putting megajoules 10 to the 6.
Oh, wait, so what's this? That's LEF, is it?
Okay.
What is?
What's LEF? LEF is latent heat of evaporation.
Right. So what's the formula of that?
Yeah, I'll do that one in a minute. Latent heat of fusion. Okay, latent heat of evaporation, the formula is delta E equals to mLEV. This one is delta E equals to mLF. These are the 2 formulas.
And L is, sorry.
L is the latent heat of fusion. L is latent, F is fusion. Latent heat of fusion. L is latent, EV is evaporation. Yeah?
So do you always use those when there's a change of state then?
We use that one when there's a change of state.
Okay.
Yeah.
Both of them, yeah.
Both of them. Yes. Yes. So
Latent heat of evaporation is F, is it?
F, yeah. No, evaporation is E. E stands for evaporation. F is fusion.
That makes sense.
Yeah.
So is fusion going into a solid?
Yeah. Fusion is from solid to liquid.
Solid to liquid.
Yeah, fused together. Yeah. And evaporation is from liquid to vapors.
What? Yeah. Fusion. What? They give you it, don't they? Yeah.
Oh, they will give you that one.
Yeah.
You don't have to memorize it. Yes. This is one thing. This is one thing. This is just one thing. Yeah. It's,
Just set only one.
yeah. LEV is one thing. Okay. Now that is given. It's that one. So if you put that in calculator, anyone got an answer for me, please?
101.
Okay. So I got an answer. 101.7 megajoules. If I want to convert 45 kilogram of water at 100 degree, water is 100 degree, to steam, I need to heat it. That's the amount of the heat energy I need to provide. If I don't provide heat energy, water will start cooling. If I provide heat energy, water is 100. Water can't go above 100. So that water, rather going about 201 degrees centigrade, water will say, I'm boiling, I'm evaporating. Water will start to evaporate. This is the amount of the heat energy I need to convert the water from liquid to vapors or to steam. Now the third part is this. Go on. Third part is this one. Now, then I heat the steam. I want to create the superheated steam. Steam is already 100 degree. I converted the steam. Now I need to superheat the steam. I want to increase the temperature of the steam to 140, 150. So how I do 150? Now superheating the steam. Now that's the third stage. Superheating the steam. So steam is at 100 degree and I want to do 150 degree. That's what I want to do. So now what is the steam? We assume it's the same mass. So the mass of the steam is still 45 kilograms. That's because I converted all 45 of the water into steam. Now I need to find out latent heat of I got the evaporation of that one, yeah. But now I got the latent heat of evaporation. Now it's not condensing. I can't do fusion. So I need a specific heat capacity of the steam. So specific capacity of the steam is how much? Is it 1040? Am I right?
No, 2010.
2010. Thank you. 2010 joules per kilogram per centigrade or Kelvin. What does this tell you? The lower the value is, the easy is it to heat. If you got 1 kilogram of water, it's difficult to heat. You need 4,200 joules of heat to increase the temperature of 1 kilogram of water from, let's say, 20 to 21 degrees centigrade. For steam, you only need half of that energy, which is 2010. So I am heating that one. So the temperature one is how much? 100 degree. And what's the temperature 2?
150.
And then I can do, thank you, change in temperature is 150 minus 100. That will be 50 degrees centigrade. Okay. Now I got formula for that one. Delta E, this is the steam now. Delta E equals to MC delta T. Let's put the values. M is still 45, the C is 2010, and that's 50. Anyone give me the value, please? So I got the value is 4.52 megajoules. So this is the value. Now the question is, what is the total heat energy required? So I'm going to add 4.52, 101.7, and 15.12. So the total heat energy that's going to be required .
101.7
Oh yeah, that's what we're all
So
excited.
it's 2.
So basically,
Equation
yeah,
2 plus equation
you sent me one price, clear on the
One,
issue.
two, and three together,
And
yeah.
then I watched you got one.
Cold War, it's
So
a
you made
hot
like
water.
several grand.
Fire.
One issue is I can never sell it.
Fire the bits in between.
Or it's serviced. Turning the drill and stops. You know?
Okay, what was the first value?
15.12.
15.12. What's the second value?
101.7.
Thank you. What was the last value?
4.52.
Okay, everything is in megajoules. Anyone got an answer for me, please?
Cold Big John.
121.34.
That's very expensive.
So this is a total amount of heat energy that's required to convert, or that's required to heat the water from 20 degrees centigrade to a superheated steam at 150 degrees centigrade. 121.34 megajoules, and that is true for 45 kilogram of water. If you increase the mass of water, you need more. If you decrease the amount of water, you need less. Okay.